Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Oh, good morning. Okay, we are starting now. Okay, so let's just look at the introduction. Then we talk about that other people will join. All right. Let me know the departments are here. What departments? What about here? Here. Phone. Yes, no. Microbiology. You're welcome. Okay. All right. Now I want us to understand graphing first. Just remove the secondary school knowledge about graphing because what we think graphing is not really what graphing is. Are you there? Now in physics or in mathematics, we have different types of graph, right? There are different types of what? Graph. Types of graph. The first is the linear graph, right? Linear graph. Second is what? We have the parabolic graph. This is also called quadratic. Quadratic what? Graph. We have what called the exponential graph. Exponential graph. We have what called the sine and what? And cosine what? Graph. We have what called the cubic. The cubic what? Graph. All of these graphs are important in mathematics and in physics. But basically for physics 107, the only graph you are doing in 107 is what? A linear what? Graph. Are you there? When you do what linear means what? A straight line graph. Hope you are aware. Now, I'll be emphasizing more on what today? On linear graph. Then the second semester we'll now go into parabolic what? Graph. What are linear graphs? Let's look at this first. A linear graph, we know they are what? They are straight line, right? They are straight line graph. Right? Their general form is what? They have a general form of y equals to what? Ms plus what? Plus c. The general form of all linear graph is y equals what? Ms plus c. When you hear the word linear means the highest power is what? 1. When you hear the word quadratic, what's quadratic? What's the highest power of quadratic graph? 2. The general form of the parabolic graph or what? Quadratic graph is what? As squared plus what? Bs plus c. Is that not? Like for example, you have 2s squared plus 4s plus 5. This is a quadratic what? Equation. Is it not? The highest power here is what? Is 2. So when the highest power is 2 becomes what? Parabolic. Parabolic or what? Quadratic. When the highest power is 3, it becomes what? Cubic. But when the highest power is 1, it becomes what? Linear. The highest power of s here is what? 1. What about y? 1. Are you there? Whether y or what? Or x. But this y represents something. Y represents dependent what? Variable. X represents what? Independent what? Variable. Are you following? The word m represents your slope. Otherwise called what? The gradient, have you? Good. Then c represents what? Intercept. It stands for intercept. Please put this down. Our emphasis is on linear graph, so I'll be emphasizing more on linear graph today. Are you following? So today, this month, the first thing you should know is that all the graph in your 107 is what? Linear. So don't be in any attempt, no matter how your point are scattered, never generate what? A parabolic what? Graph. Are you there? And I'll be showing us how to plot a graph. Yes. Yes. Linear graphs are straight line graph with a general form. The general form of linear graph is this. That's what I mean here. I started by defining the linear graph. This I was straight line what? Graph. They have the general form of what? Y equals what? Ms plus what? C. Where y represents what? Dependent what? Variable. What was an x? Independent variable. What was an m? Slope or gradient. What was a c? Intercept. When they say dependent, that means They cannot define themselves either. They depends on what? On x to define them. For example, if I have y equals to 2x plus what? 4. Y is what? Yeah, dependent, right? What is x? Yeah, independent. That means to define y, sometimes they will tell you the value of x ranges from 0, 1, 2, abi, so infinity. That means that the value of y depends on what? On x. So when x is 0, what will be your y? 2 times 0 plus 4, abi, which is what? Y equals what? Yeah, 4. So 2 times 0 is what? 0. 0 plus 4 is 4. Then when what again? When x is 1, what's the y? 2 times 1, abi, plus what? 4. That will give us what? Yeah, 6. Are you seeing it now? Now you can see how why y is called what? Dependent. Y depends on x. So y cannot define himself. It can only be defined when you know the value of what? Of x. Are you following? Okay. Now let's look at the general forms. General forms or the various forms of linear graph. Correct me here. Okay. Various forms of what? Linear what? Graph. Have I defined, you should know what slope represents, right? Slope stands for what, yeah? Your gradient, right? The word slope here, the word slope, which is our m, is changing what? Y over what? Changing what? X. Which is same as what? Y2 minus what? Y1 over what? X1. Is that not? Uh-huh. Under calculus, we call this what? Differentiation. I'm not further mathematics in secondary school. Further maths. Uh-huh. We call this what? Yeah? Differentiation. Either. But I'm not going to that. Then what's that C? The intercept. This represents the Y intercept. The Y what? Intercept. This stands for that point where the regression line cuts the Y axis. For example, now, if I have a graph like this, listen, and I have a straight line graph, the point where this line cuts the Y axis is called what? The intercept. Are you there? Are you there? So that means we can have a positive what? Intercept or what? Yeah? A negative intercept. This line can cut the negative Y. In your Cartesian diagram, this represents what? Yeah? Minus Y. This stands for what? Plus Y. This is what? Plus X. This is what? Minus X. So I can have a positive intercept or what? A negative what? Intercept, depending on your graph. Are you getting it? Uh-huh. And not all graph must start from where? The origin. Hope you are aware about that. Uh-huh. Okay. Now, the various forms of linear graph. The first one is one we have already stated, which is y equals to what? Ms plus c. The graph of this linear graph is simply of this kind. This is the graph of what? Y equals to what? Ms plus c. Any line, any graph that has a straight line has a general form of this. But it depends on where the line is what? Is cutting. Are you following? If the line is cutting here, that means my c is what? Positive. I can have a graph like this, minus c. If it's minus c, what will it cut? Negative y. Are you following? So sometimes they will give you, yeah, coming, coming, yeah, money. So sometimes they will give you an equation or they give you an experiment to conduct and they will tell you to plot a graph of this against this. Are you following? Sometimes you can determine the nature of the graph from the equation given to you. Let's say, for example, now, if we have V equals to what? IR. This is what? What law is this? Ohm's law, is that not? V equals to IR, where V represents what? Your voltage. What is your I? Your current. What is your R? Resistance, which is your constant, right? Good. Now, you might have to plot a graph of V against what? Against I. This kind of graph will be a straight line graph starting from where? The origin. You know why I knew from the origin? When you compare this now with this, let's say we have here, right? A graph of y against x. What's our m here? Slope. What's our c? Intercept. Any value attached to the independent variable is called what? The slope. The value attached to s here is what? Is m. So what's our m here? Slope. Now what is our independent variable here? A graph of v against what? I becomes what? Independence. V becomes what? Dependence. Are you following now? So that means that my slope is what here? Exactly. Now, if you enter like plus 0 here or plus anything, that means that my C is missing a bit. If since our C is missing, that means my C here is what? Is 0. So this graph we start from where? The origin. Origin means what? 0, comma what? 0. My y is there. My y is 0 here, right? All over x is also 0. So my y-intercept here is what? Is 0. So a graph of B equals to IR. Once you see this in any experiment and you have to plot your graph, just note that this graph must start from where? The origin. No matter how scattered your point is, sometimes you might end up plotting a graph like this. A graph of V. V equals to I what? IR. And maybe your points are scattered, right? You don't be wondering. For this man say, let's say I have a point here. 1, 2, and I have like 1, 2, 3, 4, 5, 6. This is a scatter graph. You don't be wondering which of these points will I use. Is that not? As well as V is what IR. This graph will start from where? The origin. And most of the time when you plot your graph, none of the points we touch what? The graph. I will show us. There are two methods of plotting the graph. We have by ratio and by what? Regression what? Analysis. Are you there? I will show us how we can plot the graph using what? Ratio or using what? Regression what? Analysis. Are you there? A perfect graph is a graph that has good what? Accuracy. A perfect graph is a graph that the line of best fit is perfect. But let me not take us through that journey. But just listen to what I'm saying. But hope you understand this concept here. That if I am to plot the graph of B against what? I, this graph must start from where? The origin. Because the intercept is what? Zero. Are you there? Any graph or any equation that has 0 intercepts must start from where? The origin. Now we say that all linear graph means a straight line graph. And all linear graph has the general form of what? Y equals what? Y equals mx plus c. All linear graph are called straight line graph with a general form of what? Y equals mx plus c. Where y represents what? Dependent variable. S represents what? Independent variable. M represents your slope or your gradient. Slope or gradient simply means what? You're changing y but changing what? X, right? Then your C represents what? Your intercept. Intercept is that point where the regression line meets with what? Y axis. Either y or negative what? Y, right? So the first form is this. Y equals ms plus c. This is the form here. Let's look at number 2. If we have y equals to what? Mx minus c. What do you think will be the nature of this graph? From those who have been here. This graph first of all, is this graph a linear graph? Is it a linear graph? Yes. Why? The highest power is what? 1. Because my c is what? A minus. This graph will cut the negative what? Y at any point. No, this is what? Negative y, right? This is what? Positive what? X. So this is a graph of what? Y equals to what? Mx minus what? C. Are you following? Huh? Are you done with this? Correct me, yeah? Okay. Here are the various forms of linear. We have seen the second case. Let's see the third one. Number 3. If we have y equals to what here? Mx. What happens to this case? This is when c equals to what? 0. The general form says what? Y equals ms plus c. But if I just have only y equals mx, it means there's no what? C. C represents what here? Your intercept. So then my intercept is at where? The origin. A graph of y equals to what? Mx is a graph that starts from where? The origin. This is a graph of what? Y equals to what? Mx. Here we have what here? Y, right? Here's what? X. A good example of this is what? Your Ohm's law, right? That says what? V equals to what? IR. When you plot a graph of voltage against your current, this graph must start from where? The origin. Are you getting it now? Okay. This is a graph of V equals to what? IR. Where V represents what? Dependent variable, right? I is what? Independent. What's the R here? Your resistance or your what? Your slope. And the slope of V, the slope of a graph of V against R is what? R. Okay. The fourth one, when, let's say when the value of n is equals to 0. We can have the case where there's no slope. After plotting your graph, there's no slope. It's possible. If such happen, let's watch. The general form is what? Y equals what? Ms plus C, abi? So y equals, when m is 0, what will it be? Up here? 0 times what here? S, abi? Plus what? C. What 0 times x? 0. So that means my y is equals to what? C. The nature of this graph is simple. This is what? Y, right? Sorry. Y axis. This is what? X axis. This graph is just like this. Straight. Are you seeing it? The graph is just a straight line graph. The line is parallel to what? The S what? Axis. Are you there? So this is when y is equals to what? C. A straight line. Slope simply means, when you hear the word slope, it means a slant line. This means there's a slope, there's a slope, there's a slope. But this means there's no what slope. If you have something like this in any graph, that means that your slope is what? 0. I cannot find change in y here. I cannot find change in what? X. Is that not? So our slope is what? 0. So put this out. Now let's look at graphing. The two methods used in graphing. Then we'll now move down to your assignments. Method of graphing. Please put this out. There are two basic methods. There are two basic methods using graphing. Number 1 is by ratio. Number 2 is by regression analysis. Let's talk about ratio first. You must have heard about ratio, I don't know. Now we have two methods using graphing. And we have by ratio and by what? Regression what? Analysis. You have to pay attention because this will really help you. Most of the times in your practical or you might just give you the experiment and you'll be asked to plot your graph immediately. Do you understand? So you can either use any of these to plot. If you're in the practical or you can really adopt what? By ratio. But when they say take it to your house or take it to your various house and plot the graph, and then count down and use what? Regression what? Analysis. The most accurate method is what? Regression analysis. This one, if you plot by ratio, there might be a chance of you introducing what? Error. Either. No, we have types of error, right? In graph. We have the standard error, the random error, systematic error, we have computational error. All of this, in my next class, I will teach error analysis and how to calculate error. There are formulas to find what? Error. Error from your graph, error from your slope, error from gravity. Are you there? We have different errors, but that will not be today. My aim today is that you're going to learn how to plot graph using what? Either by ratio or by what? Regression analysis. Are you following? Oh yeah, put this down. The following ratios are adopted. The following ratios are adopted. The following ratios are adopted in plotting a perfect graph. Number 1, 1:1. Number 2, 1:2. Number 3, 2:1. The following ratios are adopted or are used in plotting what? A perfect graph. 1 is what? 1:1. Are you there? 2 is what? 1:2. 3 is what? 2:1. We have here. We also have 3:2. We have 2:3. We can have 3:3. We can also have 3:1. We can also have 1:3. We can also have 4:2. 2:4. Yeah, money, come on. That's just it. 2:4. We can also have 5:4. 4:5. Just put this an ETC. I'll explain what we mean by ratio. Yes, I'll explain what we mean by ratio. But have you heard about it before? In physics. Okay. I will explain home direction. Now listen. Now listen. We have different types of regression graph. It cannot be perfect graph. A graph can be perfect. When I say graph is perfect, meaning that all the points in the graph passes through the lines. Are you following now? If you have a graph like this, and we have all points here, right? Huh? This is the perfect what? Graph. Perfect. In fact, this graph does not even fall among the ratios. Ratio simply means that there are some points. Sometimes if you are plotting a graph, you have a point here and that point here. This is called what? 1 ratio what? 1. Are you there? I can have like 2 points here. I have what here? 1 point here. This is what? 1 ratio 2. I can have 2 points here. I have 2 points here. This is called what? 2 ratio 2. Which is also same as what? 1 ratio 1. It's better you have 2 points and 2 points and only 1 point passes through the line. Sometimes you can plot a graph. Sometimes you can plot a graph and all the points are here. Are you following? And no points are found on what? On the line. You'll be wondering, is this graph correct? Eh? It's correct. What's the ratio here? 2 ratio 3. You can get a graph of this kind using what? Regression what? Analysis. But the mistake we always make is that we're always in a hurry to choose our what? Line of best fit. Anyhow. Like I just do have submit. No. You know, I've told you that before. Before you start plotting a graph, take that question given to you. If there is any formula given, let's say for example, now like I gave, what the formula for period of oscillation? Period is equals to what? 2 pi, right? Square root of what? L over what? Let's say G. Are you following? If you are giving this, let's say the question involves a period of oscillation of a single pendulum. Are you there? If you are asked to plot a graph of, let's say, T square against L, you don't just rush and start plotting. Are you following? Even though your graph is of this kind, let's say you have a perfect graph like this, all your points are like this. Hmm? Look at this graph is empty, right? You might be thinking, is this one? 1, 2, 3, 4, Abby? Or this, Abby? Or this? You can't even determine. Are you following? You be confused. But what will help you is what? Direction. You start using your ruler to trace. Which one? No, I should place it here. Will it be 2 or what? Or 1? Will it be, just make sure you maintain these ratios. Either 1 is to 1 or what? 1 is to 2 or what? 2 is to 1 or what? 3 is to 2. 3 is to 2 means 3 points here, Abi? 2 points here. Just avoid the graph where all the points are clustered in one what? In one place. If I have 5 points here, let's say I have 1, okay, let me use this. I have, let's say I have 1, 2, 3, 4, 5. This is what? 1 is to 5. This is a very long graph. This graph is not good. Why? Because almost all the points are what? Clustered. Some of you, because you are always in a haste to copy from your neighbor did the graph, you're not copying the same thing. You don't copy because your graph, the error in your graph is different from the error in what? Someone else's graph. So you cannot use someone else's graph and to determine yours is not possible. So you must have to use your own and do what? And plot your graph and calculate your error and leave the off. So don't be in an haste to start plotting because your neighbor said it's this. Then you have to look for a means to generate what? Either by ratio or by what? Regression what? Analysis. But my aim is to teach this now. Let me explain this. Then we'll now go into graphing proper. Open your autograph. Your autograph notes. Okay. Go and buy you. I go and get there's one at extension gate. Hmm? Oh yeah, let's watch. Can I play, yeah? Okay, let's look at regression. analysis. If you can learn this method, you won't have any issue in graphing again. You can learn this method. This method. I don't teach this, but I just have to do it. Are you following? And you won't see it in your textbook. It's not in your textbook at all. You won't see this in your textbook. Are you following? Now look at this. Under this, we know that the general form of linear what? Graph, right? Is what? Who can remind me again? Y equals to what? Ms plus what? C. The general form. All linear graph must exhibit this form. Linear graph means the highest power is what here? 1. Are you following? Y, we have defined Y as what? Dependent variable, right? What is S here? Independent. What is an M? Slope. What is a C? Intercept. Now, there's a formula for finding slope. Do you know I can determine my slope without plotting my graph? Are you aware? Are you aware? Thank God you are aware. Sometimes, it's better you calculate your slope. Then, if you're not plotting your graph, you know that you already have your slope in mind. Are you following now? Because you're not if you just go and start plotting graph, you not calculate your slope, changing what? Y, over changing what? X. The slope in your regression might give you 2.5. If you have one, let's say you have like 1.5 here, that means you are wrong. The slope under this formula can never lie. This regression analysis gives a perfect what? Slope and what? Intercepts. Are you following? Well, you can introduce an error here because if you are, by the time you are plotting your graph, maybe you use the wrong scale, or maybe you are copying from somebody, and the person had 1.5, and you also have 1.5. And someone else who did a very perfect graph using what? This analysis now got to 2.5. In fact, in YX, if you do YX now, in YX, if you do Pascal, right? You say plot what? Your graph and find your slope. They only have the slope in mind. They know what the slope is. Through this method. You are not the one trying to plot. Is it also? So if your slope is not corresponding with what they have, you are wrong. Now I will teach you how they find what slope and what intercept without plotting what graph. Then we can now use this regression to manipulate your graph to be perfect. Is that okay? Now what? So y equals what? Ms plus what? C. This M here represents what? N summation of what? Sy. Don't be scared, okay? Minus summation x dot summation what? Y. Divided by N summation s squared minus summation x all what? Or squared. That's my N. This time for what? Slope, Abby. The value of our C intercept is giving us y bar minus ms bar. Formula for C is like moving this across. This become minus ms. But difference is I have to put what here? Bar. Y bar means what? The mean of y. S bar means what? Mean of what? X. So the formula for y bar is simply what? Sum of what? Y over what? N. Y formula for S bar is what? Sum of what? X over what? N. Please put this down. These are the formulas you need under what? Regression what? Analysis. Yes. Let me have that assignment. Let's solve it here. Let's solve it here. That assignment. We are given the table. Given the table. Plot a graph of the table here is we have L, right? L we have 80.0, we have 70.0, we have 60.0, 50.0, right? 40.0, 30.0, and 20.0. Then we have T1, we have what here? T2. Then we have our period. Okay? What's our period here? 1.79, 1.59, 0. What? Is that 90? Okay. 0.80, 0. What? 60, 0.50, and 0.30. Then we have what here? Period, right? T square. So this was what was given to you in the Let me give you the value of T1 and T2. Okay, we don't really need this actually. What you need is what? L and what? And T. So what the graph says, plot a graph of L against what? T square, right? Plot a graph of what? L against what? Is that small t or capital T? Capital T, right? Good. T square. Okay. Then I give a scale. Complete the table and plot the graph of L against T square. Also find the table. Okay, let's see what we can do here. Plot the graph of L against what? T square. Okay. 2 cm. A scale was given. 2 cm to represent, is that 10 units? 10 units on what? On the y-axis, right? What again? 2 cm to represent 0.2 on the what? X-axis. This lecturer has a complete table. That's it. It's not possible. Hope you're aware. You have to conduct the experiment. Except we have only T1. I can complete what's here, the table. Huh? Well, I can manipulate it for us. Can I manipulate it? Okay. Now let's look at this. Now watch. Yes. Yes, what? Which side? Which side there? After T2. There's what? Mean T. Is that the value for here? Okay. Is that mean T given? Do you have any value there? It's empty. Okay. So here we have T2, Abi. We have what here? Mean T of this way. 1.59 is 1.50. Okay. This one. Okay, good. Okay. 1.8 what? 0. Okay. That is all. Okay. Now let's look at this. The lecturer say complete the table. You are aware that, listen, that frequency is number over what? Over time, Abi? Are you aware? Period is inverse of frequency, which is what? Time over what? Number of oscillation. How many oscillation was given? Was it 20? Okay. So when n is equals to what? Yeah? 20. Is that not? Are you following? So now look at this now. This T here represents a what? Your T what here? Average. Are you following? That means I'm going to make T as what? Subject. So my T becomes what? My big T times what? N. So my small T becomes what here? What is our big T? 1.8 for the first one. So I'll come here, let's say question 1. Then I'll say when big T equals to what? 1.8. What's our small T? 1.8 times what? Times 20, right? So that will give us what? What do you have? 30 what? 36 what, yeah? Second. So let me get something. Okay, so we have gotten our T, right? As what? 36, is that not? This is supposed to be the average, right? So that will be what? 36 point what, yeah? 0. Now, it's not left for you to manipulate this into this and this. Because T1 plus what? T2 over 2 should be equal to what? T what? Average. Abi? You are aware? So I've only got my T average as what, yeah? At 36. So that means that I can divide this into what? And let's think of a similar number. Let's think. 34.0 plus what? 38.0 divided by 2, right? That will give us what? Okay. So let's go. That will give us 34.0. You have the what? 38 point what? 38.0. Right? Okay. So when we add up this and divide by 2, that will give us what? 36. Adi? Okay, so let's look at this now. I hope you are following. You ask me, how did you guys get so bad? So let's look at when what now? When T, right, is equal to what? 1.50. So what was that small T? What's that T average, yeah? Big T times N, which is what? 1.5 times what? 20. What do you have here? What do you have? 30 what? Second. So our T average is what? Is what? 30. 30. Yes. Okay. Starting from where? How did you get 20? No, we are told it's 20 oscillation. It was given in the experiment. Are you there? Uh-huh. Do you get it now? Let's take something, please. Let's take. Divide this 36 by 20. What do you have? What do you have? 1.8. Okay. Let me, because this time. Okay. So what do you have here? 30, Abi. And let's think out this average. What do you think about it? Hmm? Let's look at 30 plus 30 is what first? 60, Abi. Sometimes we can even use the same in some cases. Let's assume that yes, what 30, yes, what? 30, Abi. For this. This for 30.10, this what? 13.0. Let's assume this is correct. Let's go into this now. When what now? When t is what? 0.9, right? 90. What do you have? Times 20, Abi. What do you have here? Huh? 18 seconds. So look, what value do we have here? Yes, what? 18, Abi. So let's vary this. What do you have? Let's use 16 plus what? 18 plus 18 is what? 36, Abi. So average should be what? 36. Is that not? So 16 plus what will give us 36 plus 20. Is the gap too much? What of 17? Plus what? 19. Will it go? Divided by 2, Abi. So let's move this. This will give us what? 17 point what? 0 plus what? 19.0, right? When you add up this, divide by 2 give us 18. Do you understand? Okay, what's the next one? Yes. Is this too much? And most of the time, what we look at is actually the average. The average. Do you understand? Just the average. A gap of 2 is also good. 2 is good. It's good. It's not advisable. Yeah. From 0, 1, and 2. 0, 1, and 2. Yes. Where? This gap here, right? So let's use what here? 35.0. What about here? 37, right? Is that okay now? 37 point what? 0. Is that okay? Okay, let's check this here. This will give us 0 point what? 0.8 times what? Times 20. That will give us what? 16. Okay, so our average is what? 16. So what do we use here? Yes, sir. Yes, go ahead. No, there's what we call the table of approximation. If you are doing a table, always add the word 0.8 points, because sometimes this value can be 35 point something. Do you understand? That's why. And already we are already giving that our capital T is what? In 2 decimal place. Let's maintain. I can even put 0 again. Hope you are aware. So what do you have here? 16, Abi? So what will be the average there? Let's think out. 15 and what? 16 plus 16 is what? Right? So 15 and what? Huh? 17, Abi? Is that okay? Huh? 15.0 plus what? 17.0, right? Okay. Multiply 0.6 by 20. What do you have? 0.6 by 20 is what? 12. Okay, so our average is what? 12, right? 12.0, please. Point 0, point what? 0, point what here? 0, right? Okay, the average there, let's go. 11 and what? 12 plus 12 give us what here? 24 over 2 is what? 12, Abi. So let's go with this. 11 plus what? Plus 13, Abi. Is that okay? 11.0 plus and what? 13.0. Are you following? Huh? When you add up these two, divide by 2, we have this. Is that not? Let's go. What's the next one there? 0. What? 5 times what? 20. What do you have? 10. Oh, this is very simple. Can I use what here? 6 and 4? Or 5 and 10 plus 10 will give us what? 20, Abi. What do you use? 9 and what? 11, Abi. 9.0 plus what? 11.0. Is that okay? What about this? 0.3 times 20 is what? Hmm? 6, abi? Let us use it to be 6.0, 6.0, 6.20. Huh? We are done with it. Now we have to plot a graph of what? Our t square, abi? On the t square means the square of this. What square of 1.80? 3.240. If you are evaluating this, put your value in what? 4 decimal place. 3 point what? 2400, right? What about this? 2.2500. What about this? 0.8100. What about this? 0.64. Huh? What about this? 0.3600. What about this? 2500. What about this? 0.09. Wow. Now let's look at something very serious case here. Now listen. We have to plot a graph of what? A graph of what? Graph of L against what? Against t square. Which formula in physics is connecting length and period of oscillation? Which formula? T equals to what? Hmm? Hmm? They're meant to give you this formula. T equals to 2 pi with what? L over what? G. Abi? Huh? Is that not? Now listen. Listen. This is where you need to pay attention. There's what we call linear graph transformation. Graph what? Transformation. Before you start plotting the graph, I give us about 4 various aspects of linear graph. Y equals to ms plus c. Y equals to ms minus c. Y equals to ms. Right? Y equals to what? C. Is that not? Now, I need to transform this equation into a linear form. Into what? A linear form. Since I'm plotting a graph of L against what? C square. A graph of what? L against what? Yeah? C square. I'll look for a means to generate T square and what? And L. How do you generate T square here? I will square both sides. So I'm transforming. Transform the what? The equation. I will square what? Yeah? Square what? Square both what? Both sides. When you square both sides, what do you have here? T squared equals to what? 2 pi square root of what? L over what? G. All what? Yeah? All squared. Are you following? So now give me what? T squared equals to what? There's a law that says that if I have AB all squared, this is same as what? A squared, B squared. So that means 2 pi will be squared, abi? Square will now cancel what? Yeah? Square root. Is that not? So that means they'll give us what? 4 pi squared dot what? L over what? G. Do you agree with me? Huh? Are you confused here? Okay, let me take it easy, right? This is same as what, yeah? 2 pi all squared. Dot what? Square root of what? L over G, right? All what? All squared. 2 squared is what? 4. Pi squared is what? Is pi squared. Square can go with what, yeah? Square root. Remaining what? L over what? G. Exactly now. Okay, so here we have T what, yeah? T squared, right? Okay. Now let's go. Here we have what, yeah? Let's finish up here. T squared, right? Equals to what? 4 pi square L over what, yeah? G. Now our aim is to find what? A graph of what, yeah? L against what? T square. That means a graph of L against T square. L represents what? Dependent variable, right? What's the T square? Independent variable. Don't forget that when we started with y equals to what? Ms plus c. Y represents what, yeah? Dependent. What's the s? Independent. A graph of y against what? X. If I have v equals to IR, a graph of v against I, your y is same as your v. V represents what? Dependent. What's your I, yeah? Independent. Are you following? What's your R, yeah? Your slope. I said any value multiplied with your independent variable is called what? Your slope. So F represents independence. So that means my M is what? Slope. Are you following? So here I represents what? Yeah? Independent. So R is all R, yeah? Slope. So this graph is SC, yeah? Is SC here? That means a graph of V against R must start from where? The origin. Because there's no what? Intercept. Please take the note I gave that this morning to help you. Those that have the note, hope you document your hold on. Okay. So that means that since the question says plot a graph of L against T square, I will now look for a means to make what? L as what? A formula. By cos, I will do what here? I'll cos multiply. That means here becomes what? T squared G equals to what? 4 pi what? L, abi? How do you make L to stand alone? Divide both what? Sides by what? 4 pi square, right? So here will give us T square G over 4 pi square is equal to what here? 4 pi square L over what here? 4 pi square. And this go with this. What's many here? L equals to what? T square G over what? 4 pi what? Square. Are you following now? A graph of L against what now? T square. What is the value multiplied with T square? If we have y equals to what? Mx. A graph of y against s. What's that slope here? M. A graph of L against T square. What's that slope here? No. G over what? 4 pi. This is same as. The whole of this is same as what? T squared times what? G over what? 4 pi what? Squared. So I can say that my L here is equals to what? T squared dot what? G over what? 4 pi what? Square. This graph, is there an intercept? Do you have our C here? When you compare this with y equals to what? Ms plus C. What's our y here? L. What's our x here? T square. What's our m here? G over 4 pi square. What's our C? 0. That means that this graph will start from where? The origin. That's the first knowledge you need. Not just picking the points and you are scattering everywhere. You getting the gist here. Now, I'm going to show you that this graph must start from the origin. And the slope is what here? What's the slope here? G over. Sometimes in your exam, practical exam, they will not tell you to find the value of G. How do you find the value of G? I will not say that, after plotting your graph, you must have gotten your slope. Let's say if your slope is 2.5. Where is your slope? Are you following? Now, if your slope is 2.5, what's that slope here again? This, Abi? Then I will not say 2.5 is equal to what? G over what? 4 pi square. Where pi is what? 22 over 7, Abi? For me, I can multiply and find what? Yeah? G. And you now see your G can be under 9.8 meter per second squared. Or sometimes 10, Abi? If you have 10.0, you see what? It's still 10. Even if you have 10.4, you see what? 10. But I will solve this in case it comes out in your next part. Now, let's solve. Okay. Now, listen. We have to plot a graph of what? L against what? T squared. That means my L is what? Y, Abi? What's my T squared? X. Are you there? So I want to use what? Regression what? Analysis. I already construct. I'll bring down my table for what? Y and what? Yeah? X. Y is L. S is what? T squared. Let's bring down the value of Y. L. What do you have here? 80.0, 70.0, 60.0, 50.0, 40.0, 30.0, 20.0. What's the value of T squared? X. What do you have there? 3.what? Just give me this one in 2 decimal place now. 2.25. What again? 0.81, 0.64, 0.36, 0.25, 0.09. Now, I give us a formula for finding regression analysis, right? Can I see here? Okay, I still writing. The next is to bring out the product of what? X and Y. Are you following? Because from the formula I gave up, you see that M is what? N summation what? Sy over what? Summation X, summation what? Y over N, summation S squared minus what? Summation X all what? All squared. That means in this table, under regression analysis, I need what first? I need X, Abi. I need what? Y. I need what? Sum of what? S and Y. I also need what? S squared only. Are you following? So that means I will create table for here. Here is what? S squared. Are you following? Now what's our SY? S times Y, right? 80 times 3.24 is what? Let's be fast about this. 80 times 3.24. What do you have there? 2 259 point what? 20. Okay? 20. There's no number there. Okay. What about this? 157.5. 5 what? 0. What about this? 48 point what? Huh? 6 0. No number there. Good. What about this? 30 what? 32 point what? 0 0. Hope you know what you're doing here. This time this, right? What about this? 14 point what? What about this? Huh? 7.50. What about this? 1 point what? 80. Now let's evaluate our S square. Someone else should be calculating the sum of what? Y for me. Calculate sum of Y. Sum everything here for me. Sum everything here for me. Sum everything here for me. But let someone else help me with this. What's our S squared? 3.24 squared means what? 3.24 times 3.24, right? That will give us what? 10.49. Good. This one should be 4 decimal places. Okay. What again? 2.0736. Huh? What about this? 0.6561. Good. What about this? 0.4096. What about this? 0.1296. What about this? Yeah. This one, yeah? Oh, sorry. 5 point what? 5.0625. Right? What of the rest? Please, let's be careful with our answers, okay? 0.25 square is what? 0.0625. What about this? 0.09 square? 0.0881. Okay, have you sum up this for me? What do you have? 350. What about this sum of y? So this sum of y, sum of x, 7.64. What about this? 521 only. What about this? Sum s square. 16. 826 what? 0. Okay. Alright. Hope you have documented this. Connect me table. Okay. This is what I need now. I don't need this again. Connect me, eh? Alright. Now let's look at this. Recall that y equals to what? ns plus c. The value of m we say represents what? N summation s y minus what? Summation x summation what? Y divided by what? N summation what? S squared minus summation x all what? All squared. So let's solve for n. N represents number of data. How many do we have here? 1, 2, 3, 4, 5, 6, 7, right? N is 7. Are you following? Times what is sum of sy? 521.0. 521.0. Okay, let's say 0.0. The minus sum of x is what? Sum of x is what? 64 times what sum of y? 350. Sum of y, right? Okay. All divided by what's our n again? 7 times what is sum of s squared? S squared. 16 points. 16 point what? 6 what? 0. Are you following? Okay. Minus, right? Sum of x all squared means what? Sum of x all squared means the sum of this x, which is what? 7.64. Then square it. What do you have? What is 7.64 squared? What do you have? 58 point what? 96. Okay. Now let's watch. So our slope becomes, so what should multiply 7 by 521 for me? 364 7 minus, multiply this, 7.64 multiply with 350. What do you have there? 2674 divided by what? Multiply this for me. 7 times 16.82. 117.782 minus, here we have 58, right? Point what? 3696. Subtract for me the numerator and the denominator. Subtract the numerator. What do you have? Subtract. What do you have? 971 973 divided by 59.4124. So let's divide this. Divide 973 by 59.4124. 16 point what? 3771. Our slope can be 16.38. Right? A graph of what against what? L against what? T square. L is in what? Meter, right? T is what? Second square. Which is what? Meter per what? Second square. So our slope here is what? Is meter per second square. Okay. So that means this slope represents what? What unit is this? Per second square rather. That is what? Acceleration, right? Okay. Okay. So let's watch. Our slope is given as that. Okay. Now, yes, ask a question. This slope, you must have this slope. You must have it. You must have something similar. Either 16.30 or 35 or do you get or 16.0. But it will not be less than 16. Graph. Now I'm just showing you this. Once I'm done with this now, I will solve the intercept. I will now show you how to manipulate it from your graph. So I can appreciate this class. So next time on your own, you can do it on your own. Can I me, But do you have anybody here who have maybe solved plot the graph before? Anybody here? So we can take their slope if it's corresponding with this. Anybody? Nobody. Okay. Okay, let's look at the next is to find what here? Intercept. Have you recall that I would say that C equals to what? Y bar minus what? MS bar, right? You say Y bar represents what? Sum of what? Y over what? N. What sum of Y? Sum of Y is what? 350. What's our N, yeah? 7. What do you have when you divide this? What do you have there? What do you have there? 50. Okay, good. 50.0. Now let's solve for what here? S bar. What's S bar? Sum of X over what? N. What's sum of X? 64 over what? 7. What do you have there? 1.01 1.91. Happy? Okay, these are about 1.1, right? Okay, these are about 1.10, right? Okay. Therefore, our C becomes what? What's our Y bar? 50.0 minus. What's our slope there? 16 point what? Give me this value. 3771, right? Times. Give me this value. 1.091. Abi? So C becomes what? 50 minus what? Multiply this to what they have here. Multiply 16 by 16.3771 by 1.091. What do you have? What do you have? 17.86 8674161. 74 is okay. So subtract this. What do you have here? Subtract. 32.136 1326. Okay. Now the values I need here, I need my slope. What's our slope here? 16 point what? 38. What's our intercept? 32.1326. What's our S bar? Our S bar is what? 1.10. What's our Y bar? 50 point what? 0. These are the values I need for my graph. Now let's plot the graph now. Are you ready to plot the graph? Any question here? Let's plot our graph. Alright, so now let's plot the graph now. Listen. The scale we are given. Okay? Yes. Of course you can, but they gave us this scale. This was given. Yes. Mm. We use 0.2. Let's take this is what here? 0.2, 0.4, 6, 8. This is 1, Abi. 1, 1.2, 1 point what? So it wouldn't be enough. This after extend, right? But your graph, will you enter your graph? That means the graph, we need to change this here. But who gave you this here?
When it was taught against T was 1 point.
Okay. We'll change our scale then. We'll change our scale. But I think this scale is okay for y-axis, Abi. 2 cm to 10 units. And to every 2 cm, we have 10. Yes, 10, 20, 30, 40, 50, 60, 70, 80, right? Then for this, we can use what here? I think we can use 2 cm to represent 0.4, right? 0.4. With 0.4 work, take your graph there. 0.8, 1.2, 1.6, 1 point what? 2 points. Okay. 2.4, 2.8, 3 point. It will be enough, Abi? 0.4 will be enough. Good. Alright. Now, listen. If you are plotting your graph, listen, avoid odd numbers in scale. Avoid something like, let's say, 2 cm to 0.3, 0.5. You get? Because by the time you divide the number of holes there by that value, it's difficult for you to get each of those holes. No, you know that in your graph, let me have the graph. Look at this. Each of it represents what? 2 cm. 2 cm. Right? In 2 cm, we have how many holes there? 10, Abi? And to get the number of what each of those holes represents, what do we do? Let's dig out this first. I'm coming. Yeah, what do you have here? These are 0 units, Abi. Here we have what here? We have 10. We have what here? 20. We have what here? We have what here? 40, 50, 60, 70, and what? 80. Abi? So here is 10. Are you there? How many holes do we have here? 10. Divide that 10 by 10. What do you have? 1. That means I guess each of those holes represents 1. Abi? Are you following? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each of those holes you are seeing represents 1 what? 1 unit. 1 what? Unit. Are you there? Now let's look at this here. What be here? We are using 0.4 now. 4 units on the x-axis. Don't forget that in your graph, your scale is always on the right hand side. Abi? You have your scale here. Is that not? Then you have your title here, right? Graph of what? And against what? Against t squared. Okay. What do you have here? 0.4. Is that not? What be here? 0.8. What be here? 1.2. What be here? 1.16. What be here? 2.0. What be here? 2.4. What be here? 2.8. What be here? 3.2. What be here? 3.6. Will this value be captured in your graph? Is it captured in your graph? Take your graph. They are all captured. Yes. Yes, one is asking the question. 0.4 because if we use 0.2, the graph will not be enough. So the only way is to expand the units. Do you guess? 0.2 cannot work on the x-axis. It's 0.4. Are you there? Okay, now can we now start now? Can we start? Can we start? Oh yeah. Fill out. Please, in plotting your graph, already we have seen that our intercept is what? Positive, Abi. So anytime you're plotting a graph, always try to leave a little space here. Are you there? Take your graph up a little. Start counting your 80 from the top downward. When you get to 0, there will be what? A line. Exactly. Uh-huh. Count your 80 from the top first. 80, 70, 60, 50, 40, 30, 20, 10, 0. Then anyone that remains with your straight line, call it what here? S-axis. So you can have more space down. Are you following? Huh? Have you done that for me? Oh yeah, do that, do that. You can just come down, come here, put 80 here, leave a space here. But the whole concept is that let there be a space on the down part. So start counting your 80 from here. Then leave a space down. Have you done that? Then the outside. Got to be inside. It doesn't really matter. Have you done that? Then draw a straight horizontal line. If you have done that, say yes. Uh-huh. Oh, yeah, put your values. Put the values. Here will be what? Yeah? 0.4, 0.8. Put those values. Huh? Are you ready to solve now? Let's solve the graph itself. Let's plot our graph. Let's start plotting the graph. Okay, now watch. Listen. Listen. When L is what? 80, right? When L is 80, what's that X here? 3.2. Now let's find the value of 3.2. We know here as 80, right? The point of intersection is what? This 2.0. 3.2 is here, right? But not just 3.2. 3.24. Are you following now? Now watch. Have I defined what each O represents here? Have I defined that? I don't think I have not. Divide for me. 0.4 by what? 10. What do you have? No. 0.4 divided by 10. 0.004, right? Are you getting it this here? That means each of these O's on the x-axis represents what? 0.04. Exactly. Okay, let me just put it down so I won't forget. X is what? 0.04. What is Y again? 1. Have you? 1 unit. Are you following? Now, 80 as against 3. What here? This is 3.2, right? What do you do with 3.2 for? Huh? Is it what? The tiny, no, this is a thick line, right? The second one, right? After it will be what? 3.24. Because if from here to that first line is 0.04. So 0.04 plus 3.2 is what? 3.24. Yeah, do that for me. Indicate it here. I'm going around. You didn't get it. This is your 80 bar. This is your what here? This is a thick line. Showing what? 3.what here? 2. Right? There's a line here. We have other lines here, right? Like 10 lines. The first one after this thick one is what? 3.24. Yes. I'll go and I'll do that for you. What is second? Well, y is what? 70. What's our x? 2.25. Now let's watch. Now watch. 0.2, not 2.4. 2.2. Thank you. Let's from here 1, 2, 3, 4, 5. Abi? 2.2. 2.2. 2 point what? 2.04 is here, Abi? 2 point what here? 08. 2 point what here? 1, 2, Abi? 2 point what here? 1, 6. 2 point what here? 2, 2.20, right? So what's the next one? 2.24. Are you following? So 2.24. That means I need just what? 0.01. Is that not? So I'll just a little in between. You know what I'm saying? I'm trying to avoid this and this. You know, I can get this from the graph. If I approximate this now, this will not be what? 0.60. So the best is just, since I can't approximate this, I should not approximate this. If you approximate this will now be for 2 point what? 3. Don't approximate. It's not advisable. Instead, when you get to that point, just divide the next hole by 2. Are you getting it this here? I'll be going right now to check your work. So, oh yeah, let's start work. The third one, are we there? 60 as against what? 0.8. Where is 0.8? Okay, this is 0. What? 81. So I will just the same way, just in between 0.8 and 0. What? 84. Just put it there. Have you done that? Are you done with this? Let's go to what now? 50, 0.64, right? This is very simple now. 0.6. Okay, 0.4. Okay, good. Let's generate. Okay, let's take together. Let's take from 0.4, right? Let's see what will happen here. Okay, that's good. Let's take 1, 2, 3, 4, 5. Are this is 0.4 plus 0.04. What do you have? 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 What of this? 6, Abi. What's the next one? 6 what? 4. Oh yeah. How many lines is there? The 6th line. Are you sure? Of course. Perfect. Abi. 6 lines. Let me show you something. This another way is this. We have 6 lines, right? 6 times 0.04 is what? So that should be 0.24, right? Are you there? Multiply 0.04 by 6. What do you have? 0.24. Is that not? Then plus what? 0.4. That will give us what? 64. Is that clear? So that means it's 6 line after 0.4. Have you done that? Can we proceed now? Okay. So the next is what? 0.36. Yes, behind 0.4. So let's go. So that will give us how many lines do you think that will be? 1, 2, 3, 4, 5, 9. 9, right? 9 times 0.04 is what? 0.36, right? Hope you get the gist. From this 0 point, count how many lines? 9. As against what? For 40. Hope you are aware. So I think somewhere here, right? For this, okay. Then for this is somewhere where? Yeah, right? For 50, 0.64. Somewhere here, right? No, this graph is not perfect. Yours will be started, but I'll show you the perfect graph. Don't worry. Okay. What the next one? 0. What? 25. 0.25. 25. What will it be? 0.04, right? On the 6th, the middle. Okay. Between the 6th and what? The 7th, Abi? Have you achieved that? Have you done that? Okay. What's the next one now? 0. What? 09. How did I achieve that? The second. In between the first and second. The second box divided by 2. Okay, 0.04. Of course. Look at it here. Listen. This is 0.04, Abi. 0.08. So between the second and the third, Abi. Second and what? Third. Are we done? Maybe the next class I'll explain. Now let's put our graph. Now, do me a favor. Are we done with these points? Are we done with these points? Do me a favor. What this is our S bar. S bar is what? What's our S bar, yeah? 1.09, right? Or 1.10. Let's use 1.009. Let's watch. I'll bring down my S bar and what? My Y bar coordinates. 1.09 should be. I'll plot a graph of S bar against what now? Y bar. Or Y bar against what? S bar. All you will be doing what? Y against what? X. So let's generate the graph of what? Y bar and what? S bar. Are you following? What's our Y bar? Y bar is 50, Abi. 50 as against what? Yeah? 1.1. 1.09, right? Let's check. This is 50. This is 1, Abi. This is 1.2. Should be between this and this, right? So let's go. Let's take 0. What? Yeah? Let's bring out this. 1, 2, 3, 4, 5. This is 0.8, Abi. Plus 0.04. What do you have here? Huh? 0.84, right? Plus 0.04. What do you have here? 88, Abi. So that means between what? 0.88. Have you achieved that? Plus 0.04. What do you have? 92. We have exceeded 0.92. That means between the second and what? And the third. You know what points? Oh, 0.8 plus 0.04 is what? 0.184. 0. Plus 0.04. What do you have? 88. Yes, what? 92. What about here? 96. What about here? 1.1 here? 0 B plus 0.0. Huh? 1.4 plus 0.04. 0.8. So in between what and what? I wasn't counting the numbers or the lines. Between what and what? How many lines? Or I take the 7th and what? 8. Huh? 7th and what? And 8. Please demarcate. Let me confirm it again. The 7th number. 7 times 0.04 is 0.28. Perfect. Then plus 0.8. Against 50, yes. Against 50. Wow. Somewhere here, right? Huh? Right? Somewhere here, right? So what you do for me here is that you circle this one for me. 1, 2, 3, 4, 5, 6, 7, 8. Have you done that? Now, bring that your intercept for me. What's the intercept? 32.1326 on the y-axis. Yes. Between what and what? This, Abi? 32 should be here, right? So locate it from here. Just from here. What do we say C represents? Your intercept. Is that not? Okay, locate it from here. Locate your C. Yes. What is the C? Each of these represents what? 1, Abi. This is 30, Abi. 31, 32. So somewhere here, right? Have you done that? Circle it for me. Now, draw a straight line. Draw a straight line that will connect this intercept with your mean. Let me see what you achieve. No, now you don't need to enter. Manually does that. Draw a line that connects this your what C and your mean here. Without that point enter, I don't care. Just draw. That's what I need. Eh? What ratio? 4:2.
I'll write my title of that.
Exactly.
My skill.
Your scale will be here. Yes, put your scale here. Your scale will be on the right hand side, Abi. The graph will be where? The middle. Are you following? Then you put your what here? Your length, Abi, in centimeter. Your time is what? So is that time? What is that? T squared, right? As what? S squared. Are you following? Okay, now let's find the slope. Sorry, briefly, I will summarize this. The mistake we always make in slope finding is that, let's say we have a point, Abi. We have good points, Abi. You're always tempted to take your slope from those points, right? If you do that, you introduce what? Error in the slope. Error in what? In the slope. So you don't take your slope from those points. You take your slope from any point on the what? Line. Is that clear? So that means, that's why I say, those points that scattered are not necessary. As long as you have gotten your line, you can get your what? Your slope. Is that clear? Now let's go. On your own, decide your slope from your graph. So take it from here. Anywhere? From here. Huh? Have you done that? Okay, please. Yes. Our slope is M, Abi. Which is change in what? Change in L over what? Change in what? T squared. That will give us what? L2 minus what? L1, right? Over what? T2 square minus what? T1 square, right? Let's go. What's that L2? You come here. This is your L2, Abi. Locate that point here to this point. What is the value here? 80 minus, for this graph I'm having here, I have 30, 31, 32, 33, 33 over. Let me take now for your T2. Yeah, are you there? Locate the value of your T here on the x-axis. If your slope is this now, this is my what here? My what here? L2 abi. This is my what here? L1. This is my what here? T2. T2. This is my what here? T1. Are you there? So what's your T2? Please wait for me. 1, 2, 3. 0.04 times 3. 0.04 times 3 is what? Wait for me. 0.4 times 3 plus 2.8 plus 2.8 2.92 minus, okay, then this point here for this graph 1 2 0.04 times 2 0.08 or 0.08. So you have subtract this for me. Let's take 80 minus 3 47 over, what do you have here? Be fast. 2.884. We have divide this, what do you have? Divide 47 by 2.84. 16.54. What do you have as a slope under regression? 16 point what? 38. Abi? Are you seeing the difference now? Are you seeing it? Are you seeing it? Why do we have this value? Why do we have this value? Because of some certain errors we introduced, which I said I'll teach us how to find what error in what in graph. Then I will now teach us how to differentiate, how to find the error between this and what and this. But there must be some similarities. Abi, what do they have here? 16 and what? 16. Are you following? Okay. Your own is what? 16.81. Perfect. It's good. 16.38. Very good. 16.48. 16 points. 15 points. 15.83. Please take your work again. But that can approximate to what? 16 abi 0.00. It's still manageable. In my next class, we look at what? Yeah? Error what? Error analysis. In our next class, then we look at how to transform. Transformation of graph. Of what? Of graph. Graph transformation and error analysis. Next class on Saturday.